Hey everyone, so the purpose of this video is to walk you through how I use Tableau or data visualization tools in general. This applies to Power BI, even just Excel, to help me in the machine learning process. So if you're watching this video as part of my class, you've already gone through and we've had a couple days where we talked about dashboard theory and data visualization theory. You've hopefully also gone through, if not in this class, some prior point, the getting started video on Tableau. It'll teach you all about how to make dashboards and stories. That's great. There's a lot of power in tools like Power BI and Tableau. That's not how I'm going to use it though. The way I like to use it is to actually just help me identify potential relationships among variables that can be sources of prediction or explanation or ways to enhance my machine learning models. So let's do this with the bike buyers data set that we'll use commonly in this course. So you can download it here if you're in the class, or if you're watching this from YouTube, there's probably a link in the description to that download file. So anyway, I'm going to assume you have that. Let's go ahead and open up a Microsoft Excel file. Here it is in my downloads, bike buyers. Looks like I've got a few versions of it already. And let's pull in this Numeric tab into the data pane. Tableau, I'll have to control it later. Anyway, so here's our field. As a reminder, each record here is an instance of a person buying a bike. Now, for starters, all right, a lot of my students struggle with, why am I doing this, or what am I doing this for? So let's get ourselves out of student mode and out of doing what your professor tells you mode and into I'm in a job and I've got to figure out how to do my job mode. In other words, you're an analyst and you've been tasked with explaining why people are buying bikes or why they don't, why they do it, so that we can do a better job of marketing our bikes, of choosing which bikes to offer. We're looking for any potential sources of knowledge or information that can help us in our bike shop to explain or help us sell bikes, basically. So what a lot of students struggle with is up until this point in their education, they're very used to being told, this is what you need to learn. This is the one right answer to every problem. Read it, memorize it, regurgitate it on an exam. You'll have to get out of that mode now in data analytics, especially right now with data visualization, because your only overarching goal here is to beat your competitors. There is no one right answer of how to do that. It's all going to come back to how, one, what skills do you have, and two, how creative you are. How you can go about recombining those skills into useful data, information, knowledge that you can use to beat your competitors with. So, in other words, long story short, I can't tell you what the one thing is you need to learn to memorize. I can just show you some skills. Then it's up to you from there to be creative and create your own new knowledge. That's really what we're doing, is we're researching here. We're generating our own knowledge about what it takes to be competitive, in this case, in the consumer bike market. So all we can do is take a look at the data we have and the tools we have, and then be creative from there. So here's our data. Customer information, marital status, gender. Notice if this is your first time seeing this data, I've got two different versions of some of the same variables, a numeric version of marital status and a text version. So here I've got married and single people. As you'll learn throughout this course, sometimes we need that data in numeric form, so I created a 1, 0. That's how we convert text into numeric data. It's a binary version. We'll get into later in this course how do I handle categorical variables when there's more than two values. I can't just make it a 0, 1, 2. For example, what if I had married, single, and divorced? I can't just go 0, 1, 2 because that implies an order. That implies that somehow married people are greater than single people, and then if I coded divorced as 2, that would imply that divorced people are then greater than married people. So don't worry about that for now. We'll handle that issue later. For now, just notice all the different columns we have. Commute distance, how far they travel from work to home. Education numeric, there is an order to that variable because over here in education, a certain level of education implies a greater than other levels of education. So I was able to, even though there was 5 different versions of education over here, I was able to rank order those. I also have this purchase bike numeric. So here's my dependent or my outcome variable that I'm interested in, purchase bike. So let's start by identifying that one. My most important outcome here is whether or not someone's going to buy my products. That's what I'm trying to encourage or fix or enhance or do something with. Everything else region, commute distance, whether or not they own a home, their occupation, education, age, number of cars they own, number of children, income. These are all data points that might help me explain whether they were a yes or a no when it comes to purchasing a bike. Or I've got the numeric version right here. So the first step is I'm identifying outcomes and inputs, causes and effect. Now, I can't, if you're, the statisticians will roll their eyes at this, because I can't establish causality with secondary data like this, data that's already been collected. However, we're going to imply causality. We're going to use theory and prior knowledge to say, okay, if people live farther from work, they're more like, or live closer to work maybe, they're more likely to purchase a bike because they could use a bike to get them there rather than having to drive 40 miles. They couldn't bike 40 miles, for example. So my theory says that yes, living further or closer to work does affect whether or not they'd purchase a bike. So I'm going to imply that there's some causal relationship there, even though technically, according to the rules of causality, I can't say for sure. But let's not worry about that right now. So knowing that purchase bike is my variable of interest, it's my potential dependent or outcome variable, I'm going to start creating visualizations to help me understand why people did or didn't purchase bikes. And I'm just going to start two at a time. Let's look at all pairs of variables. We call that bivariate statistics or bivariate relationships. I want to look at each variable and their relationship to my variable of interest, my dependent variable purchase bike. So let's go to our first worksheet and let's grab purchase bike. I like the numeric version because it allows me to do a little bit more with it. I'm going to put it either in rows or columns. Let's not worry about it. As you know, hopefully you're already familiar with Tableau. You get that when I've got a measure, a numeric field, it's going to automatically apply some sort of aggregate function to that field. But let's grab a dimension, a categorical field. Let's start with something as simple as region. Does the region they live in imply that there will be differences in bike purchasing patterns? So I like the vertical bar charts a bit better for that. So at a first glance, because I see differences in the lengths of these bars, this is the sum of people who purchase bikes, I can see that there's some difference across region. North America is clearly higher than Europe, higher than Pacific. However, I can't just take this now as gospel truth. North Americans buy more bikes. The question is do North Americans buy more bikes per person who comes into my bike shop than Europe and Pacific, than these other regions? So, for example, it could be simply that I have more bike shops in North America. So, and that's why I have more bike sales there. This is a sum of total purchases, and each purchase is represented by a 1 right here in the data source. So I can't look at this and say, yes, North Americans buy more. So I need to modify my visualization a bit. For example, let's change sum to average. So for this tells me then, this also that now takes into account those who came into the shop and didn't purchase bikes. So the idea here is I want to create visualizations with pairs of relationships and then modify my measures to make sure that I'm accurately comparing the values across these categories. So let's do this for each categorical dimension, and then let's switch over to the measures. Each pairs of variables where the other variable besides purchase bike is numeric and not categorical. So pause the video and go ahead and make a visualization for each one of these, and let's interpret all of them. All right, I have each of my charts made now. Let's go through these. Now in each of them, I'm looking at the differences in the category across whether or not they purchased a bike, and I've averaged it out. That's because I don't have a perfectly even number of records of people in Europe, North America, and the Pacific, because I have different purchasing volumes or different interests in each one of these areas. So I take an average of purchase bike numeric so that I'm controlling for the differences in my sample size across each category in the data. So based on this, I would say just by looking at it, it appears that I have more people in the Pacific who come into my stores who choose to purchase a bike than in Europe and North America. Now this doesn't tell me if this difference is statistically significant, but it tells me that this could be a source of useful information when it comes time later down the road to learn predictive analytics, when it comes time to predict who will and won't purchase a bike. This tells me that, region where they live is indicative. Now, just because I live in the Pacific, that doesn't mean that it's the region that's causing me to buy more bikes. Rather, there's a whole host of other variables about that region. For example, in the Pacific, maybe there's in those locations, maybe people generally live closer, or bike costs are generally, or maybe the cost of alternatives, cars and other things, are generally more expensive, so people are more likely to purchase. So it's not that living in the Pacific causes me to buy more bikes. It's just simply that those who live in the Pacific, that's representative of a host of other factors that are likely to actually cause me to purchase more bikes. But I'm going to look at this and remember, okay, region. In fact, I'm going to give this one a star right here because I see big differences in these bars. That tells me this is likely to be a good source of explanation when it comes to predicting whether or not someone will purchase a bike. So let's take a look at commute distance. Once again, I've averaged across the different commute distance options, and it looks like 2 to 5 miles seems to be the sweet spot. Generally, you see this downward trend. So the further away people get from work, further their homes get away from work, the less likely they are to purchase a bike. Now, theoretically, that makes sense, right? The further away people live, the more likely they're going to want to drive. However, you have this sweet spot right here in the middle. 2 to 5 miles seems to be a good distance to travel to work by bike. Doesn't take too long, but it's not so close that you might just want to walk or something like that. So this tells us one explanation for what I'm seeing here is that people buy our bikes to commute to work. They're not just solely for recreation. People like to commute because that makes sense, that's a good commute distance. So once again, I think this could be a good variable to help us differentiate or explain whether or not someone will purchase a bike. And I conclude that because I see great differences here among these bars. The other thing I conclude from this chart is that it's not a linear relationship, meaning as the commute distance gets greater, it doesn't necessarily go down for every value. Generally, overall, yeah, there probably is a line you could draw that'll go like that, but I have this exception right here to the rule. So we'll remember that or make a note of it for later on in our analyses. So notice here with education, it does look like I have some trend going down, but hold on, take a look down here. These levels of education, because the data for education in the field that I used is text, it's categorical. That means that Tableau doesn't understand that bachelor's is less than graduate degree and that partial college is less than bachelor's. Rather, it's ordered these things numeric or alphabetically, which is what this means. Actually, no, it's ordered it greatest to least right here. So if I want this to show up in order of education, what I have to do is instead of using the dimension for education, I have to use this education numeric, and I would have to change this to be dimension so that it doesn't think it's a number. Rather, the number shows up as it would sort it alphabetically based on that number. But anyway, let's not worry about that. I can just look at this and say, okay, look, the lowest is partial high school. So people with low education are buying fewer bikes. Then when high school is completed, they buy more. Partial college doesn't seem to be much of a difference between those. And then bachelor's is the most, and it goes down slightly for graduate degrees. So there might be a little bit of a trend in terms of as you get more education, you buy more bikes. But there might be a better explanation for that. It could be simply that as people make more money, they buy more bikes. But I don't know for sure. But again, since I see big differences among at least some of these levels of education, I'm going to conclude, I'm going to start because I'm going to say, yep, this could be a useful variable in predicting whether or not someone purchases a bike. All right, gender. Those lines are very similar. It doesn't appear that gender differentiates really whether or not people purchase a bike, so I'm going to leave that one alone. Homeowner, same thing. Not much of a difference between those, relatively speaking. Just so you know, later on we can still test to see if just because it doesn't look like there's a big difference doesn't mean this variable isn't statistically significant. But in terms of its practical significance, the difference is only 48.6 to 47.5. It's 1% basically. So I'm not going to start or worry about it. Same thing with homeowner. Marital status. Now I am seeing a big difference. Married people buy fewer bikes than single people. Now we could explain that with a number of other factors. It could be once you're married, people are more likely to have kids and they have less money for buying bikes. However, they'd be buying their kids' bikes. So I'm not sure what to think. Why married people here buy fewer bikes than single, but the difference in the height of these bars is big enough that I'm going to star this as something to take a closer look at later on. Occupation. Yeah, I see a big difference between management and professional, but I don't know. I'm kind of hesitant to conclude because a lot of the average of these bars is, I don't know. I'm not going to star occupation. So let's move on now and look at measures. Let's make a new chart. Let's once again put in purchase bike numeric, and let's grab one of our measures like age. Drop that in there. Now, first thing you see is it's just going to sum, because the default aggregator is the sum function. It just says add up all of them, which results in one dot. So the sum of all ages here is 44,000, and the sum of all purchased bikes is here about 481. That means out of my data set of 1,000 people, 481 of them purchased bikes, because I've got purchased bike numeric recorded as a 1 if they purchased, 0 if they didn't. This is not helpful. So what we need to do is either change this to an average, or better yet, let's disaggregate the data. So you can't see it, but I've got up here in my toolbar the analysis tab. Click on that and you'll see the aggregate. I better move this up so you can see it. Oh, I can't go that far, can I? Let's see what I can do. If I click analysis, now you can see it right here, aggregate measures. Deselect that. Let me pull this back down again. Okay, my data is lined up here on 0 and 1. That's because my values for purchase bike numeric are all 0s and 1s. Whenever you have ordinal data, which means there are no decimals, it's rank ordered, it's not continuous data where I could get decimal places, it lines up all on those integers. And it's tough to see, okay, it looks like people who didn't buy a bike, it's because so many of the records are on top of each other. For example, this circle, there could be, I don't know how many people are represented by that circle right there. Basically, everyone who's age 31 that didn't purchase a bike is represented with that dot, and I don't know how many of those there are. So this doesn't do me a lot of good. Here's what I'm going to do instead. Come up here and, actually over here on analytics, let's grab a trend line and drop that in here under linear. All right, this is more useful. So this says if I were to draw a line that minimizes the difference between each dot and that line. So this is it's a predictive line. It says that people who are 10 years old, we predict that they would buy a bike, whatever that is, 65% of the time. Well, that's not realistic. We don't have anybody in our data set who's 10. So we don't want to make a prediction in that range where we don't have any data. But let's come over here. For people who are 27-ish or 25-ish, we predict that they would buy bikes 55% of the time. So basically, as people get older, they buy fewer and fewer of our bikes. That's what this line means. Now, we'll spend much more time on this later on. But here's how I'd interpret this. Because that line is at an angle and not perfectly flat, that tells me that there is some relationship between age and whether or not they purchased a bike. Furthermore, you can see there in the data that comes up as I hover over the line, it has this thing called an R-squared value and a p-value. We'll cover those more later, but know that because that p-value is very, very low, the lower that p-value gets, the steeper the line gets, the lower that p-value gets. And one rule of thumb that I don't necessarily subscribe to, but most people do, is that when that p-value gets below 0.05, that means that that angle of the line is statistically significant, meaning it's not likely due to chance, meaning there truly is some relationship between their age and whether or not they purchase a bike. So I'm going to take that angle of the line, and I don't care whether the line angles down or up. If it goes down, it just means that as one goes up, the other goes down. If the line were to go this direction, it just means as people get older, they'd purchase bikes. Either way, I don't care. As long as this line isn't perfectly flat, that means there's a relationship between these variables. So I'm going to say age star. I like using age as an indicator. Now, being older or younger isn't by itself a reason to buy a bike. Rather, it's other factors like as age goes up, maybe I have fewer kids, they grow up and move out as I get into these ages, and I don't have a reason to buy them bikes anymore. That could be one explanation. But we want to come up with theories or explanations for why we're seeing what we're seeing and remember those. So for now, what I want you to do is pause, and go back to data and create a visualization for the remaining measures against purchase by Numeric. Oh yeah, and for each of them, add a trend line. Oh, disaggregate the data and add a trend line and take a look at it. All right, so made my all of my scatter plots and trend lines. We did age before, so let's go to cars next. So here's my cars, purchase bike 1, 0. In my data set, looks like I have data points of people with 0, 1, 2, 3, and 4 cars even. Wow. Anyway, so my trend line also goes down here. I think that makes sense. As people have more cars, they're less likely to be wanting bikes for commuting, or maybe it could be because they're spending all their money on cars, they don't have money for bikes. There could be a number of explanations for this. It's good to think through those. However, for right now, I just want to, again, note that the angle of the line is pretty steep and that p-value is definitely below 0.05. You'll notice, again, we'll learn later about what r squared means in that formula up top, but for now, you'll notice that the r squared gets bigger as the p-value gets lower, generally speaking. So for this one, I'm going to say, yep, cars is good. I put a star on it. We're going to keep that. Oh, you know what? I forgot children. Hold on. Let me add my sheet here for children. Sorry to waste your time there on that. Let me drop in children, purchase bike Numeric, disaggregate, trend line, right there. Okay, once again, it looks like age, cars, and children seem to go together well. All of them as they get higher, well, that makes sense. As people get older, they buy more cars, they have more kids. These are three very related variables. Now later on when I want to do some predictive analytics, I'm probably not going to want to use all of them if they're very highly correlated or highly related to each other. And that's something that I'm noting now, that these three variables seem to change similarly together. As they all get bigger, they go down. Anyway, let me hover over this. Yep, very small p-value. That's enough that I'm going to star it because it's below 0.05. That means that angle of that line is statistically significant. So I'm going to note that as potentially useful variable. Commute distance, also going down, but for a different reason. As people get further away, we noticed this before. Now this is my numeric version of this same one over here that's categorical. Remember how we noticed that as commute distance goes higher, purchase bike seems to go down with this big exception right here. But that's why I like to have both charts. This tells me, yes, as I go along greater distances of higher commute distances, it goes down, and that p-value is significant. However, even though I'm going to note that with the star, I want to keep in mind that when I looked at the categorical version, there was this one big exception. All right, let's keep going here. Education. All right, this says as education goes up, and here's where I've got that. I've converted smaller levels of education to higher numbers. So this is partial high school, partial college, bachelor's, graduate. So it does look like as people get more education, they do purchase more bikes, and that p-value is significant. But let's remember, with the categorical version of this chart, all right, bachelor's and graduate actually flip. This goes in order. If let's sort this the other direction. So there we go. So this is the lowest, next lowest, middle, but bachelor's and college are reversed. But you know, they're not so different that I'm worried about that. Generally speaking, this just says as people go from no education or partial high school up to bachelor's, it seems to get higher. All right, so we'll talk a lot more in this class about whether we should use the categorical or numeric version of education in our later analyses. But for now, I'll just start that and move on. Gender, line is totally flat. This seems to agree with our bar chart here that there wasn't much difference between these lines. And this confirms with that high p-value way above 0.05 that gender just doesn't matter when it comes to determining who's going to purchase our bikes. Okay, good to know. Home ownership, now we had the categorical version over here that I said, it doesn't look like there's a difference, so I didn't star it. Let's look at the numeric version. Hover over this, p-value is 0.54, much well above 0.05, so that seems to agree with my guess over here that there was no difference. But it's good to check both charts. One, the numeric version of the chart, if I can create a binary version, a 0-1 version, this allows me to look at the p-value to see if the difference is significant. However, the nice thing about the bar versions of these charts is that it lets me identify exceptions to the rule where a line doesn't necessarily, a trend line doesn't hold true for every value. Anyway, I'm going to keep those unstarred. Income. All right, income, like age and cars and children, is a variable that we don't have a categorical version for. So we have to look at this numeric one in the trend line. Now the p-value here is 0.18. That means that angle, that as people get more money, this says they buy more of my bikes, they're more likely to go to a 1 than a 0. That's how I'm concluding that. Anyway, this angle is not so steep that our p-value is below 0.05. So for now I'll leave it unstarred, but I suspect we may still find this useful later. All right, marital status, last one. That line looks fairly steep and the p-value is well below 0.05, so we're going to say, yep, marital status, like we thought over here when we looked at it. We thought there was a big difference here. Now don't be confused. Single is coded over here as a 0. That's why here it appears to be going up, and over here it appears to be going down. It just says as they transition from single to married or married to single, there's not really an order to those two. It just means that single people buy more bikes than married people. Okay, this is a start. This is not all we're going to do with data visualization in this course, but it helps me understand the relationships between all of these variables with purchase bike numeric. That's how I use data visualization when it comes to doing machine learning. This is just a starting point to help me explore the data. I'm going to do much more advanced things with the data later on.